If you guys remember a little thing that we talked about in the past, the 1 billion row challenge. I've been needing to post that video for a while. I think it's been delayed now for like 3 months. Yeah, the 1 billion row challenge. I recorded it in February, but as I was scheduling it again, and I was thinking about it a bit more, I decided to play a bit more. So it's a project I made where I was playing with writing Go code just to see how fast I could read the rows and count the lines. So if I go back to the code I had here originally, I'm just gonna do that. It would be very easy for me to store all of these lines and append these new values as I get them. But I just want to read this text file because, reminder, this file is 13 gigs. That is a .text that is 13.8 gigabytes. It has 1 billion rows in it. This is a text file with 1 billion rows. You can confirm that by wc-l, the file. But I'm not going to just wc-l. I'm going to time wc-l. Because I want you guys to see how long WC takes just to count the lines. Still waiting. Still waiting. There's going to be a lot of this in this video. I'm so sorry, FaZe. Don't chop it. We got 11.93 seconds for WC just to count the number of rows in the file. We're in chaos land now, boys. So I have this Go code here. Function read file, takes in a file name, have a deferred file close, which if you're not familiar with Go syntax, this means that when everything else in this function is done, this happens afterwards. It's almost like a cleanup function. It's a really nice pattern. Other languages are starting to copy it. And when I do things like this, I see the value because now I'm able to put this file close call super close to where I open the file rather than like putting this at the end or ideally having some type of callback where that will fire after the return happens. Just doesn't have any of this. Defer is a really nice pattern for just keeping the things that are similar located together. So this is where the file IO is handled. This is where the scanner is created and done. And this doesn't have to blend into other things. Like the pieces aren't leaking into each other as much, which is really nice. And when I did work at Go, at Twitch for a while, I did find this nice. And having a pile of defers scattered throughout that almost always did the thing you want them to was quality. There's still a lot of little things I hate, and I'm sure we'll go over those as we go because Go is not the only language we're talking about today. But this was solid. Let me go build it quick because I want to show one of my other favorite things. You see how long that took to build? Do you know how foreign this is to me as a TypeScript dev? The idea of a build taking 0.08 seconds is like funny to me. It's even funnier to me because they should have a watch feature because if it's this fast to compile, let me -- watch and just rerun it when I make changes. But despite that, and I've seen this a lot with Go, it feels like they kind of ignore developer experience beyond the code. Like the setup for Go sucks. The package management's quirky and weird and global. All of these things are just kind of weird. Like the way that Go works is strange. The code is pretty clean and consistent. And once you have everything set up the way you want on your machine, awesome, you're good to go. But God, it's weird. And yes, I know, chat, there are things where I can add my own watching, like air, but those aren't built into Go, right? That's a package, right? Because like I know that JavaScript does this wrong too. I'm not going to pretend that Node has these things handled. They have Node watch, right? Like watch got added to Node. Yeah. 1811 has watch. So like we have watch in Node now. Really nice to have it in Go. But yeah, air is a Go air. I wonder if this will find anything I want. Yeah. Live reload for Go apps. Like it exists. People have made it, but like this should just be part of the language. Like why can't I just -- watch on a Go process? The reason is because Go is for building a binary and then you run the binary separately. Just a weird quirk. It'd be nice if they consider these things more. As Yvonne says, Go is weird, but all languages have their quirks and features. Yes, but those quirks and features say a lot about the intent and the design goals of the language. And the things I'm seeing here are that Go's focuses on the language, not on the features around the language, the DX around the language, those types of things. But man, it's nice that this code is so simple. And like, as we look here, there's no manual memory allocation. There's no references to memory at all. There's a little bit of types like file name, string, and this has to return an int or an error. I was playing with some things where I was running into issues with 64-bit ints and ints, even in code that was being referenced with, I asked Copilot and ChatGPT to help me out, and the results were often like issues between ints and uint64s. Once you get over those quirks, it's fine, but not having to worry about memory or all those things is great. And to just defer a file close and not have to worry about the file staying open, oh, so nice. So let's take a look at this really primitive thing, which again has a var for line count. And we're just increasing the count by 1 for every line for scanner.scan because we're making a line scanner here, by the way. Buff.io new scanner. And when you scanner.scan, it actually will read line by default. which is really nice. Buff.io is cracked. And the performance that I've seen from this is nuts. Like it's really, really nuts. Let's take a look at this again, single-threaded, really rudimentary solution where we're just in one simple call here, for looping over all the contents until we're out of them and increasing the line count every time. We don't want to go build. I want to go back up a directory, time./go. Shouldn't be too much longer. Come on. Yeah, 15 seconds. So marginally slower than WC. Not bad considering that all WC does is parse files. And this is very, very simple single-threaded rudimentary code. So that's not too bad. I'm going to show you an optimized version. But before I do that, I want to show you the JavaScript version. I made a couple JavaScript versions. I was just curious. In Node, we have a thing called readline. It's actually quite handy to, in Node, have a readline option for file stuff. So here I create the file stream, which is to the 13.8 gigabyte measurements text file. Readline.create interface, input file stream, the delays, infinity. This note got snuck in from something I copy pasted this from. We use the CRLF delay option to recognize all instances of CRLF, which are all the different types of line breaks in the input file. Cool. Now we have line count 0, 408, const line of RL. I still love 408 syntax. I need to use this more. It's really handy for stuff like this. We increase line count by 1 for each of these. Total lines in the file is as follows. One important detail here that makes the performance characteristics very different is that we're not actually reading the line inside of this Go file because I commented out the scanner.txt call. To get a fair comparison, we should probably scanner.txt. I don't want to print it, so I'm just going to call it. Hopefully it doesn't get too mad at me for doing that because Go's compilers, considering how rudimentary it is, it's actually pretty good at stuff like this. What the hell did I do? I'll just scanner.txt. And let's see what the performance characteristics look like now that we're actually scanning each line. So I think it to be a good bit worse, but hopefully not too much worse.
No. Listen, we're cutting that shit.
See the difference there? It's from 15.05 seconds to 16.91. So now that we're reading the text, even if we're not doing anything with it, at least we know the performance difference there. So going from not reading the text to reading the text, small percentage increase. I wanted to compare this to Node, though. So let's do that. Let's run this code in Node. And before y'all ask, why am I not using Hyperfine? It's because you don't get an output on Hyperfine that is anything beyond the benchmarks, and it likes to run things multiple times. I just want to run it once and see what the output time is. Pretty simple. But yeah, this will take a minute. This won't take as long as other solutions we'll be trying, funny enough. This is not the slowest thing we'll be playing with, but it's slow enough that I think it's worth talking about. If I look a little older now, it's because of how long that took. Still got the right answer, 1 billion. And believe it or not, some of the solutions I tried, especially the ChatGPT solutions I tried, I got a wide variety of answers that were not 1 billion, which was amusing to try and debug why I was off by like millions. But the important piece here is that this took 223 seconds. 223 seconds compared to Go taking like 15. So yeah, not great. As I was showing before, the Go code, despite being single-threaded and really simple, is a full order of magnitude faster than just reading it through JavaScript, but we can do better. Here's a less synchronous solution. Actually, no, this one's still sync. We tried some async solutions where we would chunk the file up and parallel thread it, but parsing a file for line ends in parallel is obnoxious. And all of the things I tried either got wrong answers or errored out, and I had some Go like lunatics making these recommendations. If I hop in here, lots of ways to improve it too. Partition files, yada, yada. And all the examples that I was getting from this code gen were just wrong. Like that's, I don't know. I'm not great at numbers, but that's not a billion. Like I don't think a number that begins with 7 is a billion unless we're using some really weird base. But 700826645 that's 700 million, not a billion. But again, I'm not a math guy. Hard to know for sure. The answer is also interesting because it takes advantage of some optimizations in the bytes package. IO on a single file will probably throttle across multiple Go funcs. But this answer that John found here was actually really interesting. Function line counter, buff, count, line sep. So we're setting the separator as the byte code for \n. And then we're just hunting through each character, trying to find those as fast as possible. So let's run this solution. I have the code here, count file sync. Still the same OS open to open the file stuff, but then I pass the file IO to the line counter function. line counter function is that function. Takes in an IO reader, returns int and error. Buff is make array byte. This is our buffer. \n is the new line delimiter. Now for C, comma, error, r.read buff. This is getting the chunk for this buffer. So we get 32 times 1024 characters buffer from the string here. And now we're counting how many of those bytes match the line step. So if this happened to grab 7 lines, cool. If it happened to grab 1 line, cool. Doesn't matter. And we have the switch, which for some reason did not prettier the way I would like. I'm going to go format this actually. I haven't used enough go format. That's how go format formats switch statements. Y'all are weird. You Go people are so strange. No, to each their own. Swift does this too. I want to like Go formatting because I credit Go specifically for the idea of having formatting be a language concern. It's funny because earlier I was saying like Go doesn't do a lot of things I want my language to. Like it doesn't have features like watch, but they do have a formatter. And having a formatter built into your language is awesome. I really like that idea because it means all the conversations we would normally have bickering over formatting can be ignored if Go format has an opinion already. Just use the opinions of Rob Pike. Even if they're not good, just use them so we can stop bitching and move on. Same reason why I don't have a prettier config when I can avoid it. I'd rather just let prettier's opinions be our opinions. If we have our own personal ones, cool, A+, good for you. Let the code base be the code base. Regardless, I hate this. I really hate switch statements being like that. Ugh. At the very, very least, explicit returns are nice. The other language we'll be looking at doesn't have those, and it's one of the few things I don't like about it. We'll get there, though, because I want to build and then run this theoretically much faster version. So go build, and then time./go 1 BRTC or BRC testing. Look at that, 0.32 seconds. Reminder that WC-L took 11 seconds. So this is significantly faster than what we were doing before. This is hilarious that the fastest solution I have found thus far in any language I'm willing to write to just count the amount of rows in a file, which admittedly is not a real problem. But once you're taking advantage of like buffers like this, whew, look at that speed. A lot of people were thinking this task would be IO bound because it's a 13.8 gig file. That's got to take forever, right? Like how is this possibly being slowed down by your language? I hope this helps prove that that's the case because a lot of people assumed big file, there's your problem. No. Speaking of big files and problems, I need to show this. I'm not going to be running this one again because the time is here. Phase, feel free to censor the time so we can reveal it later because I want to play with Gleam. The time here was not great, and I want to show you just how not great. But first, I want to show you what is great, which is the language. Here is me trying to read all of the lines from this file using Gleam. If you're not familiar with Gleam, you should watch more Primogen videos because he's been talking about it a lot. He did a whole video about the newest 1.2 update, which is a really cool update because it shows that they're really thinking about the user experience developing with Gleam, as well as the reliability by focusing on fault-tolerant stuff, as well as nice changes to like the feedback the server gives you when you're writing the code and the feedback the compiler gives you when you're trying to like build it. Before, it was not clear about some of these things, and they fixed it. They're doing really cool stuff. I like Gleam a lot. There's a lot of promise in this language. It's a fun balance of something like Elixir, something a little more type safe and tiny bit more OO. Fascinating language, has a couple characteristics I don't love. We'll get to all that in a bit, so I want to dive in here first. We have our main function. Let assert OK stream is file stream.openReadText measurements.txt. Cool. This is just us getting a stream. The OK stream here is saying that we are asserting that this is OK. So instead of doing the value comma error, this is the equivalent. And since we have an assert here, it's just going to throw if we don't like it. Prime recently did a video where he was talking all about how he loves asserts and thinks we should use them more. I hope he has time to play with Gleam a bit because they lean into this a lot. It's actually really nice to explicitly say, fuck you, just do this. Ignore the error, but in such an explicit way where it's part of the variable definition to wrap this with an assert OK. I thought that was nice. Anyways, we now have our stream, which I then pass to readline. But since we're doing this the functional programming Elixir way, and as far as I know, there is no traditional loop in Gleam. Instead of looping with like a while or for condition, you instead loop with functions and recursion calls. So where things get a little messy because we have to call readline with a default value, in this case 0. So here's the function, readline. Takes an x, which is an integer, and stream, which is a file stream. Let next line equal file stream.readline stream. One more thing I need to call out is the package I am using for this. I go back to the Gleam site. They have a list of packages. So I did what any sane person would do. I command F for file. And there's a couple things in here that are notable. One is simplifile. Simplifile actually looks really interesting and promising. Simplifile provides synchronous operations for working with files and directories that work for all non-browser targets, Erlang, Node, Dino, and Bun. This is an important detail because as they say in this description, which is, by the way, it's small, but this is one of the most honest top of readmes I've ever read. Simplifile makes a simple trade-off. It confines itself to a subset of purely synchronous file and directory utilities so that it can have one API for all targets. Erlang and JavaScript have fundamentally different concurrency models, so binding to async code will simply be different for different targets. You should use Simplify if 1. The same code running on JS and Erlang targets is important. 2. Sync file operations will not be a major performance bottleneck, dev tooling, configuration, scripting, etc. And 3. You just want to do some basic file operations and get on with life. If you think you need a different solution, these projects may be helpful. File streams, Erlang target. Might see what I ended up doing. Gleam library that provides access to Erlang file streams. File streams is a different file package. And if we keep searching here, we'll eventually run into file streams. Gleam library that provides access to Erlang's file streams. So theoretically, this should be much faster. We need to talk about the code a bit before I actually show the performance characteristics though. Because here I have a case statement. And it's a case statement that pattern matches, which is so nice. The underscores here work similar to underscores in like JavaScript where it's ignore this, but I can put a value here like line contents. And now this is the content of that line. So if I wanted to print it or something, I have it. And the OK and error wrappers are part of the condition that's being checked. The way pattern matching works is it takes this value, whatever next line is, and it goes through each of these conditions until one matches. Part of matching is OK or error. So in the file stream read line code, if I go back to the GitHub for it, you'll see in this example, reading a file as a binary stream. Open read, test.txt, and we can read bytes, we can get the toString, and this is all asserts to show you that like this hello world is the content of the test.txt file. You see that because we write it above here, but there's just a file that says hello world and then has an end line. So I can confirm specific characters that are inside of this. That's what this is supposed to show you. But also I can confirm error, file stream error.eof, when we actually get to the end of the stream once we've read everything that's inside of there. Simple stuff, convenient stuff. Cool they did this way. I like the OK and error patterns. They're super explicit. And if you use them alongside something like a case statement, oof, this is so convenient. But what is it doing with these values? Good question, because at this point, my biggest complaint with Gleam, and I'll admit, potential skill issue, I might just get over this. The lack of return kills me. Because what is happening here, since these are the last evaluated lines in this function, these get returned. I've never been a fan of that. I know that like your return's already at the bottom, but the lack of an early return, the inability to read and immediately see that this is a return, and the fact that this return condition is so many tabs and so far a distance from the bottom. I did my time in Elixir. I've done my time in Ruby. I just like return. I am what I am. People are complaining about no explicit return type. I'm pretty sure you can do explicit return types in Gleam. But fuck that, no need. As you see when I hover over here, it knows an integer is what's being returned at the end. We're good, it's fine. But to read these conditions, to be clear, if the next line we got from the file stream read line is okay, we read it. If it's error, we return the value instead. So this will eventually, since it's recursive, if it's okay, we call it again. Over and over, each time we increment x by 1 with the recursive call until eventually we have the answer. And if it's error, we just return that, and that ends up being the thing that pushes up, like redo style, as the final answer. So I would run this code, and believe me, I want to, but the stream's already gone for too long, so I'm going to show you the result when I ran it earlier. 1,571 seconds. Roughly the same multiplicative difference from Go to JavaScript as it was from JavaScript to Gleam here. Pain. Straight pain. I was excited to use the syntax that felt a little more fun to me because I love functional programming. I love these types of patterns. I love the pattern matching and all these things. But there's a lot of places that this could be optimized. And I had a lot of theories. Is this because we're calling a nearly infinite number of functions? Is this because we're doing a billion function calls that this is so slow? Is this slow because file I/O is rough? Like, what are the reasons that make this take so long to do? I complained on Twitter because I thought this would be faster, and I was honestly kind of surprised. So I tagged in Louis asking why. If you don't know Louis, they're the creator of Gleam, great developer, fascinating individual. Really, really responsive and great to chat with. I've talked with them a few times at this point. And I thought that just posting this with a link to the GIFs would get this cleared up pretty quick. And I probably was skill issuing myself. As you see here with Gleam Run, this took 1,571 seconds. And I think they missed that because the response was, I don't think we have any bindings to Erlang's fast file streaming APIs. The Gleam peeps are all doing web and not file stuff. You could read the Erlang docs to write bindings to whatever is best, but I imagine you don't want to. and you're booting the entire VM and loading code. You likely want to benchmark inside programs unless what you're interested in is measuring how fast the runtime boots. The speed of the runtime booting, hopefully, is negligible within a 1,571 second budget. Like, if we were comparing millisecond response times, yeah, that should be accounted for. But I am trying to figure out why this took almost like half an hour to run when other things could do it in half of a second. This is not as simple as the VM takes too long to spin up. So I was actually a little frustrated with this reply. This was 12 times slower than JavaScript was. 115 seconds to 1,571. I thought the file package I used was specifically meant to take advantage of Erlang streams. That blows. There's a few gotchas with file I/O in Erlang, like most things in Erlang, so likely lots of room for improvement. Looks like it's doing file I/O by bouncing the context via some Erlang processes, which means a lot of copying. Super slow. Should be fixable. Thankfully, Louis decided to jump in on this, and they opened up an issue based on my experience. Slow performance iterating over a file in the file streams project. Hello. Theo was doing some benchmarking and discovered that this library is very slow, 12 times slower than Node. Seeing as this is likely a library you want to use in performance-critical parts of your application, it'd be good to optimize this. It looks like raw mode isn't being used. It's often a good place to start. Perhaps it should always use raw mode, rather than expecting the programmer to know about tuning file I/O performance on Erlang. Useful feedback. I've not done any performance testing to date. That's a little scary. And again, part of why using new languages can be scary, because even if Gleam is a really fast language, if there's no way to read files reasonably quickly, that's a huge part of why you might want to use something like this. And I was excited to potentially use this for stuff like Advent of Code. But if it takes this long to read a file, that would legitimately impact my ability to do Advent of Code if it's a long enough input in a language like this. This is very much new language issues, and having these types of things not as part of the language means a much longer tail as to when we'll get these things fixed. Hi again. Turns out I just wasted a bunch of time trying to move back to version 0.4.4 before reading the next paragraph, which, by the way, somebody's writing an issue about your specific experience. Read the whole thing before you try to do things. Raw mode should likely be re-enabled for binary file streams, but that wouldn't help Theo's situation as he wants to read UTF-8 lines, which as far as I can tell means using io.getLine as file.readLine, which doesn't do UTF-8, which means raw mode can't be used. Maybe better performance could be achieved by sticking to binary raw streams and handling text encoding concerns somewhere other than the I/O module. Initial testing results. Current v5 of the library takes over 15 minutes to read and count a billion lines. I stopped timing at 15 minutes. Using raw mode and file.readLine reduced this to around 9 minutes, with the caveat that it doesn't work correctly with arbitrary UTF-8 text as detailed above. A simple Rust implementation streaming in and counting the lines took around 53 seconds. Also funny, the Rust solution was not much faster than the JavaScript one, but I digress. It's on a MacBook Pro M2 with 1 terabyte SSD, which is almost the exact same spec I'm on, by the way, so very comparable. Also, we were testing with some different read-ahead buffer sizes as well to see what impact that has, but yes, it's currently over an order of magnitude slower than Rust. Excited to see what going deeper looks like. I'll be sure to link this issue in the description of the video, so if you want to take a look as well, you can feel free to. Somebody pointed out, very fairly, that Giacomo showed up out of nowhere and made a much faster solution. They made it faster by using the Erlang streaming API, which got roughly the same performance as Node. And here's the gist with that code. If you're curious about this code, I'll link it in the description so you can feel free to play with it. Notably though, there's an Erlang file. And now that I've thrown in my editor, I've learned that there is no Erlang syntax highlighting by default. And also, Prettier doesn't like Erlang. These things aren't surprising, but they are a little sad. I pronounced Giacomo's name wrong. I'm sorry, guys. I'm terrible with names. But Giacomo is the individual who did this name. Thank you so much for that. Let's grab their alternative code here. Gonna swap this out quick, change this to measurements.txt, so I don't want to rename the file. Time Gleam run. And now we shall see how much faster this is. Giacomo. Sorry, guys. Naming pronunciation is hard. Thank you, Giacomo, regardless. Oh, he's on Twitch too. Good shit. Thank you all again. Okay. Nowhere near as bad. Faster than JS by quite a bit, but still also quite a bit slower than Go. Nice to see these types of wins, but also kind of rough to have to go into Erlang for that. Even with syntax highlighting, this is not the most readable thing for developers that were born within the last 40 years. Like, Erlang was a magical language, and the Erlang VM enabled magical things. The dashes, I guess case of isn't too bad, but they have to know enough Erlang to jump in and do this, and to know that like semicolons are significant and such. It's a weird language. It's a weird language. And double language dipping, yeah. Like, people complain about using Go on the back end and JavaScript on the front end. What about Gleam on the back end and Erlang on the back end? Theoretically, there's a future where we'll never have to write any Erlang. Like, I did Elixir for over a year in production. We never had to write any any code in Erlang as Elixir devs. And Gleam and Elixir are very similar in the sense that they're both languages on top of Erlang in the Erlang OTP. So makes sense. I'm sure these things will improve over time. But yeah, I was surprised you had to hop into Erlang in order to write that code properly, so to speak. On the bright side, though, this proves that recursively calling a function 1 billion times isn't that much overhead, which when you think about it is kind of nuts. The do line count function, 1 billion times, 1 0 0 0 0 0 0 0 0 0 times. Got it right the first time. I'm a pro. Yeah, insanity though. Like, it's crazy that any language, but this is obviously an Erlang benefit, the fact that you can just call something like that infinitely and it's fine. Good old, as chat pointed out, tail call optimizations for tail call recursions. You don't create 1 billion stack frames because of tail call optimizations. Yep, really goes fast. I know, it's cheap, but the fact that this works 1 billion times in a reasonable number of seconds is still something that I consider cool. Remember, we're JavaScript devs here. The idea of tail call optimizations is a foreign concept to us because we don't even know what tails are. But yeah, as people are saying in chat, Beam is amazing. Yeah, the Beam virtual machine is just cracked. The things it can do are unbelievable. We don't write Erlang code, but we have a syntax to use Erlang modules. Yep, and this is, for context, Ryan Winchester is one of the Elixir gods. So this is the difference between a language that's 12 years old. It was originally announced back in 2009, so even older than that, versus one that's about a year old. Big difference here. But I wanted to call that out because I was really surprised by a lot of random things as I did this. Things like how slow readline was, how much slower things like that were in other languages like Rust. The fact that somebody built this in Rust, as they mentioned in the issue here, and that even the Rust solution took 52 plus seconds, which again kind of highlights the point I was trying to make of the best language isn't the one that's objectively the fastest, because yes, Rust is objectively the fastest. But when you have the right packages, the right ecosystem, the right tools, and you throw something like what I was showing here in, just having buff IO as the way of doing IO in Go means the simple, stupid solution like this, with no concurrency, no optimizations, just doing the obvious thing of reading line by line and incrementing a counter, is more than fast enough to just do it this way in Go and get back to work. So I actually think Go is a huge winner here. Not because when I did it with this super performant buffer solution that it was the fastest, but because the really dumb, simple version like this is super readable and more than fast enough. But if you do have optimizations to make, you can. Go's not going to get in your way. It's just going to be a really simple, easy, maintainable, cuttable, copy, pastable, interactable solution. And this was impressive to me. This was the thing Go has been sold on for a while. It lets you go back to work. And I liked that a lot about it. The JavaScript solutions were fascinating. And as surprised as I was that I could get even close to reasonable performance here, it was a bigger surprise that it was faster than Gleam and Erlang. I didn't try an Elixir solution. I didn't run a Rust solution myself, but from everything I've seen, not significantly better here. But one last thing, so everybody was asking, what about Bun? I thought Bun would be a pretty quick thing to implement here, but Bun's file stuff doesn't have anything to work with here. I was actually quite disappointed that Bun didn't have any reasonable way to read line by line. Apparently they had implemented readline though, so I gave that a shot. I just ran this with Bun instead of running it with Node, and it ran for an hour and used all my CPU, and nothing happened. So I have to assume it's broken. It might just take forever, but at this point in time, believe it or not, Bun is the slowest solution I tried. So let that be as it is. Proposal, bun.lines. In order to solve my problem and possibly make Bun one of the fastest solutions, Jared proposed he'd implement bun.lines, which would do this in the Zig layer and then just give you access to it in JS, which theoretically should be super, super fast. Excited for if they end up actually shipping this. I'll definitely give it a shot, but yeah, very early. Let's summarize my thoughts and what I've learned after playing with all of these languages. Yes, I was impressed with Go. Yes, I'm probably going to keep writing JavaScript and TypeScript, but I'm seeing some very promising things happening over here in Gleam land. I like the syntax a lot. I like pipes so much and I miss them dearly. I like having types. I didn't have any time where I wrote an error and I wasn't getting feedback about it, which is something I will admit happened a decent bit in Elixir. Not as much as I would expect, but a lot. So having none of that here was really nice. And also, I know it's like a small thing and also I'm popular, so I'm going to get treated differently. But having within hours of me mentioning this, having the Gleam language creators show up and give really useful feedback, having them be honest that they made misassumptions, but most importantly, having them go open issues on the libraries that I was having these performance issues with, and having another core team member show up, make something faster, and then give me a gist with it. When you make technology bets, you're not just betting on the way the technology works, you're betting on the team too. And if I've gotten anything from this experience, is that the Gleam team is cracked. They are in, and they seem to be in for the long haul. So as long as they can stay funded enough to continue this, I see a very bright future for Gleam. But if I didn't point out the need for sponsors, I would feel dishonest. If you made it this far, you're probably a nerd about these things. And if you watch my channel in the first place, there's a decent chance you make tech money. If you could, consider becoming a sponsor. And if you work at a company that does open source sponsorships, see if you can bring this up with them, because you'd be amazed how far one corporate sponsor can go for a project like this. One corporate sponsor dropping 20 to 50K a year could be a massive difference for a team like this. It could be the difference between one of them needing to go get a job or not. Even your own $10 a month being thrown in a project like this can go so far. So yeah, hate to go and shill a whole bunch at the end, but this team has impressed the hell out of me. The language is super promising. And if these weird standard lib cases can be handled, most of my problems go away. And I could actually see a bright future where I'm using Gleam for a lot more stuff. Super promising language, super promising team. And I think it is a super promising future. Let me know what you think in the comments. Until next time, peace nerds.